An inequality is a non-equal comparison of two quantities. When we look at inequalities, there are four symbols that we use. The first is the less than symbol. This means less than, and sometimes you can also see fewer than. This symbol is the less than or equal to symbol. This symbol means less than or equal to, no more than, does not exceed, or at most. This symbol is the greater than symbol, which means greater than, more than, or exceeds. And the final symbol is the greater than or equals to symbol. This means greater than or equal to, at least, or no less than. When we look at solutions to inequalities, it's similar to looking at solutions to equations, except that we have to understand what the inequality symbol means. This problem says, is x equals 14 a solution to the inequality? Well, we can substitute 14 in for x. So instead of x minus 8, I can write 14 minus 8, and then I can write the rest of my inequality, which says is greater than 3. Then I would solve 14 minus 8, which would be 6, and then the rest of my inequality says is greater than 3. Now, if this were an equation, I would say that x equals 14 is not a solution because 6 is not equal to 3. But this is not an equation, this is an inequality. And what I need to do is look at this statement, which is 6 is greater than 3. And I have to ask myself, is that true? Is 6 greater than 3? Well, yes, 6 is greater than 3, which means 14 is a possible solution to this inequality. So yes, x equals 14 is a solution to this inequality. Is x equals 5 a solution to the inequality? Well, again, I can plug in 5 for x, so I would write 5 plus 4 is less than 7, and then I would solve 5 plus 4 to get 9, and then I have 9 is less than 7. Well, now I need to ask myself, is this true? Is 9 less than 7? Well, no, I know that 9 is actually greater than 7, so this is not true, which means x equals 5 is not a solution to the inequality. Is x equals 12 a solution to the inequality? Well, I can substitute 12 in for x. So this says 4 times x, so I'm going to write 4 times 12 is less than or equal to 48. And then I'm going to solve. 4 times 12 gives me 48. And then I have is less than or equal to 48. Now I ask myself, is 48 less than or equal to 48? Well, I know that 48 is not less than 48, but I know that it is equal to 48, and because this symbol has the equal to sign, then yes, this is a solution. Now this problem looks very similar to the last, but there is a slight difference. So again, is x equals 12 a solution to 4x is less than 48? Again, I'm going to substitute 12 in for x. So instead of 4 times x, I'm going to write 4 times 12 is less than 48. Then 4 times 12 is 48. And now my inequality says 48 is less than 48. And I have to ask myself if this is true. Now, if this said 48 equals 48, then it would be true. But 48 is not less than 48 because they are actually equal to each other. So in this case, 12 would not be a solution to this inequality. Is x equals 15 a solution to this inequality? I'm going to substitute 15 for x, and then I'm going to rewrite the rest of the inequality. 15 minus 3 is 2, and then my inequality says 2 is greater than or equal to 3. Well, I know that 2 is not greater than 3, and 2 is also not equal to 3, so this is not true, which means x equals 15 is not a possible solution to this inequality. Now, inequalities can be graphed on a number line. This inequality says x is less than 9. If I graph this on a number line, and I can place 9 here, which means this would be 10, 11, 12, 13, 14, and these would be 8, 7, 6, 5, and 4. If I were to place x is less than 9 on the number line, I would go to 9, and the first thing I would do is put a circle. Now, what I need to remember is that there is a difference between an open circle and a closed circle. In this inequality, I see that x is less than 9. It does not say that x is also equal to 9. So since 9 is not actually a solution to this inequality, I am going to leave my circle open. Then I need to show all of the possible values of x. An inequality actually has an infinite number of solutions because x can be everything that is less than 9. So to show that x can be everything less than 9, I have the open circle on 9 to show that 9 is not a solution. And then I am going to shade on my number line to the left to show that all of the values that are less than 9, which is to the left of 9 on a number line, are possible solutions. So everything down here is a possible solution to the inequality. Looking at it from a graph standpoint can help you figure out what solutions are possible. So if I said, is x equals 7 a solution? You can look on your number line and you can see that everything this way is a solution, and 7 is part of that. So yes, x equals 7 would be a solution. I can ask, would x equal 13 be a solution? If I look on my number line, I see that 13 is here, and nothing above 9 is a solution. So x equals 13 is not a possible solution to that inequality. I can also say, is x equals 1 a solution? Well, you notice that 1 isn't actually on my number line, but if I continue going to the left, this arrow tells me that everything to the left on my number line is still a solution. So if I continue further down, I know that 1 would be down here on my number line, and yes, that would be a solution to my inequality. Now I'm going to graph x is greater than or equal to 4. So I'm going to fill in my number line. And the first thing I'm going to do is go to the number that is here, which is 4, and I'm going to circle 4. Now I need to know if that 4 circle should be opened or closed. So I need to look at my symbol. My symbol says that x can be greater than 4 or equal to 4. Because x can equal 4, that means that 4 is a possible solution. So since 4 is a possible solution, I am going to close my circle on 4. Now I know that x can equal 4, but x can also be anything that is greater than 4. So to show that x can be any number that is greater than 4, I am going to shade on my number line to the right of 4. All of the values that are to the right of 4 on a number line, including those that continue on that we can't see, would be possible solutions to the inequality x is greater than or equal to 4. Next, we have x is less than or equal to 18. If I put these numbers on my number line, the first thing that I'm going to do is circle my solution of 18. And now I need to know, should that circle be opened or closed? My symbol says that x is less than or equal to 18. And since x can equal 18, I'm going to have a closed circle to show that 18 is a possible value of this inequality. Then I need to shade all of the possible solutions of x. I know that x could be equal to 18, but x can also be less than 18. So to show that x can be every number that is less than 18, I am going to shade on my number line to the left. This means that every value to the left of 18 on a number line, including those that go further down that we can't see, are possible solutions to this inequality. Next, I have x is greater than 5. So I'm going to start by putting numbers on my number line. And then I'm going to go to 5 and put a circle. And I need to know if the circle should be opened or closed. When I look at my inequality symbol, I see that x is greater than 5, but this doesn't tell me that x is also equal to 5. That means that 5 cannot possibly be a solution. So I'm going to put an open circle on 5 to show that it is not a solution. However, everything greater than 5 is a solution. That includes things like fractions and decimals. So 5.1, 5 and 1/2, 5 and 1/3. All of these are possible solutions of x because they are greater than 5. So I am going to show these solutions on the number line by shading my number line to the right. This means that every value to the right of 5 on the number line, again, including those we can't see, are solutions to this inequality. Now we're going to write and graph inequalities based on real-world scenarios. This problem says that Eric needs more than $120 to go to summer camp. Well, to write an inequality for this, I'm going to start with what I need, which is the amount of money, X. And then I see that Eric needs more than $120 to go to camp. I need to ask myself what that means. More than typically means above, so I know that I'm going to use the greater than symbol. Now what I want to know is, should I use greater than or should I use greater than or equal to? Well, we need to look at our situation, which says that Eric needs more than $120. Because Eric needs more than $120, that doesn't say that he needs $120 or more. That means he needs at least more than $120. Because he needs more than that, I'm actually only going to use the greater than symbol. So the amount of money that Eric needs is greater than $120. So if I put this on my number line, I'm going to start by putting numbers. And I'm going to go to 120 on my number line. I know that x is greater than 120, which means 120 is not a possible solution. He needs more than $120, even if that's $120.01. He needs more. So to show that he needs more than this, I'm also going to shade to the right of 120 to show all of the values that could be solutions to this inequality. Next, I see that there are at most 25 baseball cards in Muhammad's collection. Well, my key word here is at most. I know that I'm going to use X and I'm going to use 25 because this is representing how many baseball cards are in Muhammad's collection. But then I need to figure out what inequality symbol to use. When I see at most means that Muhammad could have exactly 25, or he could have below that, because the most number of cards that he has is 25, which means he can have 25 or fewer. So the symbol that I'm going to use is less than or equal to, because I know he can have equal to 25 or he can have below 25. So I'm going to put this on my number line. I'm going to circle 25. I know that this can equal 25, so I'm going to put a closed circle for 25 to show that Muhammad could have exactly 25 baseball cards. And then because that's the most number he has, that means that all of the other numbers he could have are less than that, so I am going to shade to the left on my number line. Finally, I see that Janice has fewer than 12 pencils in her book bag. Fewer than is my key word here. And I know that she has fewer than 12 in her book bag, so I'm going to use X and 12. If Janice has fewer than 12, that means that there is less than 12 pencils in her book bag. Because it says fewer than instead of fewer than or exactly 12, I know that it's less than instead of less than or equal to. So I'm going to put my numbers on my number line, and then I'm going to circle 12. Because my symbol is only less than, that means that Janice does not have exactly 12, and now I can shade to the left of 12 on my number line. Next, I see Tevin needs to collect at least 4 canned goods to attend his school fundraising celebration. So my keyword here is at least, and I know that Tevin has to collect at least 4. If Tevin has to collect at least four, then I know that he can collect exactly 4. And if he needs to collect at least 4, then that means he can collect 4 or he can collect more than that. So the symbol I'm going to use is greater than or equal to. Now I'm going to put my numbers on my number line, and then I'm going to graph. So I'm going to go to 4 and put my circle. I know that x is greater than or equal to 4, and since x can equal 4, I'm going to put a closed circle for 4, and then x is everything equal to 4 or greater. So I am going to shade to the right to show that x can be any number greater than 4.